There we go.
Are the middle school and elementary schools, do they have like a different?
Yes. They have neon today. Because they still have to do uniform for most of the things, so they have different different spirit days. So my calendar gets very crowded, knocking them all down.
Because you have the high school ones and then you have
And the elementary, or the middle school ones.
Take
Yes. I have glitter everywhere over here.
We love glitter, so it's
It is my rug is very, very sparkly.
I mean, that's normal, so. I'm actually kind of surprised Dulce came in today. She sounds no good.
They're two different.
All right. Let's get going here. We're going to start in section 3.4. We finished out 3.3 yesterday. And this is all about functions. We're going to wind up talking domain and range for some things. We're going to get into all kinds of funky stuff with functions, including operations. We're going to get into composition, all that kind of jazz. But the first thing we got to figure out is things that are and are not functions. So this is the way the book writes it, which is aggressively mathematic-y and like feels super complicated. So a function f, this is just what its name is. We usually write this with our like f of x, that kind of thing. It's just its name. You can use F, we can use G, we can use H, we can use pretty much any letter except E or I. From one set to another. From the input, so the input, which is pretty much our X values, to some other set of numbers, the output, which would be our Y values or the F of X values. In a way that, so it's a correspondence, in a way that each X goes to exactly one Y. So each input has only one output. Each X goes to only one Y. When I substitute in an X of 2, I get one answer. I shouldn't get, for a single input value, a single X value, 2 or negative 2, 4 or negative 4. Should only get one answer. So when we do this with things like tables, we're going to look and see if our x's have any repeats. We need to make sure that our x's go to only one y. When we're looking at pictures, graphs, we have a super duper high-tech fancy schmancy tool. The steek. This would be when we check to make sure each of our x values goes to only one y value, so we make sure that our vertical line only crosses at one point, vertical line test. That would make it a function. And when we're looking at equations, we're going to pretty much just have that y is going to equal something. If I could have it be a y equals, not a plus or minus. So y won't be squared, y won't have kind of funky things going on with powers. So we're going to look at 3 examples. I didn't pre-print them out for you. If you want to write the whole thing down, you can. You don't have to have the exact details on it. You don't need the proper picture of the graph. A little sketchy sketch would be fine. We want to see if these are functions or if these are not functions. So we've got a table here, we've got an equation here, and we've got a squiggle. So if we're looking at a table, we want to know, does each x go to only one y? So I want one x to go to one y. It does not matter if the y's repeat, they're totally fine. I just basically need to make sure that my x's aren't repeating. So here we've got an x of -2 with a y of -7, x of -1, x of 0, x of 1, and x of 2. Do we have any x values that have more than one answer over here? No. So this, each x value goes to only one y value, that's a function. When we're thinking about functions, kind of a mental visualization that works as a vending machine. If I hit the Coke button, I expect to get a Coke. If I hit the Mountain Dew button, I expect to get a Mountain Dew. If I hit the Coke button and I could get Sprite or Mountain Dew or Coke or water, that machine is malfunctioning. It is not a function. So each x, each button I push should give me one answer.
Or they just put the stuff in on.
But then it's a malfunction. That machine is not functioning correctly. So this one is each x is going to only one y. This is a function. Sure. This middle one, x squared plus y squared equals 15. What does that look like? What is that shape? That's a circle. I'm going to say, we've got a circle. Or x squared plus y squared equals 15. Is this a function? No. If I hold my super high technical fancy stick up here, I'm not crossing my function at all, and then all of a sudden, boom, crossing it twice. If I ever cross a vertical line more than one time, it is not a function. So this fails the vertical line test, which I will almost never write out vertical line test. Vertical line test, I put VLT. Sounds like a delicious sandwich.
I had a BLT last night.
I love VLTs.
It was from Jimmy John's too.
Nice. So the other way you can think of this is if we look at our equations here, the fact that my y is squared is what's causing our problem. If I had a y equals, so if I had like y equals the square root, or we had our semicircles, then it would be a function because it's only covering half of the graph. So if we have y squared, it's not going to be a function. This one on the right, what do we think about this one? Is this a function or not a function? Not a function. Here it's not crossing my function at all. Here it is. So when we have a picture, we use the super duper high-tech fancy schmancy tool of a steak. This is not a function. This one is also not a function. So since this crosses a vertical line more than one time, and this one crosses a vertical line more than one time, these are not functions. Functions will have each x goes to only one answer. So if it was just that part, this part would be a function if the rest of this graph didn't exist, because then each x went to only one y. It's the repeatingness of it that causes our problems. Okay, get it. My feet are gonna hurt if I do the one shoe thing all day. Because I gotta find my other shoe. Okay. So for the most part, when we're telling if things are or are not functions, it's going to be pictures or do our x's repeat. The next thing we're going to have a lot of is like substituting and evaluating. So we'll be given a function and asked to do some evaluating. So if f of x equals x over x minus 5, and we want to evaluate f of -2, f of 0, and f of 5. What are we going to do with that? Substitute those numbers in. So There we go, screen, thank you. We have, this thing is called f of x. That's its name. We've named him Fred. That's what the F stands for. It is Y in disguise. He is in a very bad disguise. He's basically doing this with a finger mustache. He says, I am Y. I am hiding. I am f of x. That is my disguise. But what we're doing is we're replacing in f of x the x with the minus 2. So if we want to evaluate f of negative 2, we're going to take our function that was our x, which we now want to have as our negative 2, over our x, which is negative 2, minus 5. So when we simplify this, well, in my numerator, those parentheses aren't doing much, so I got my negative 2. In my denominator, we have negative 2 minus 5. What do we get there? Negative 7. Can negative 2 over negative 7 simplify? To just 2/7. The negative over the negative cancels out. So 2/7. So f of negative 2 equals 2/7. That's our answer. It's substitute and simplify as much as we can. We can do the same thing with f of 0. It's the same vibe. We're just substituting in a different number. Here we're going to substitute in that 0 in place of the x. So the process is still the same. We're still going to have our x get replaced with our 0. And then this x is going to get replaced with our 0 minus 5. Well, we got our numerator of 0 and our denominator 0 minus 5, negative 5. What is 0 divided by negative 5? 0. So f of 0 is 0. One more like this. But we're going to do f of 5. Same process. We're going to substitute in place of our x, the 5, in both places, minus 5. Our numerator is 5. What's our denominator? 0. So what does this simplify down to be? Undefined. F of 5 is undefined. Because we cannot divide by 0. Okay. Questions on these 3? Because we've done this before. It's just been a while. It's an algebra 2 thing. Okay. Let's do this again, and we're going to kick it up a little notch. So we're going to do another one. Here we've given f of x. We've got a quadratic. We've got minus x squared plus 4x minus 5. And it's going to start to get a little bit wilder. We have f of negative 2, f of 2x, and f of x plus 4. So on some of these, we're not just going to get a numerical answer. We'll wind up with an equation. And that's okay. That's intended. So the first one is 100% the exact same like we were just doing, where I'm going to substitute in my negative 2 in place of the x. So if I substitute in that negative 2 in place of the x, we're going to have our minus negative 2 squared plus 4 times negative 2 minus 5. Substituting in that negative 2 in place of all of the x's. And we're going to simplify. So we have our Opposite of negative 2 squared is going to give us a 4. 4 times negative 2 is going to give us a minus 8. And then we have minus 5. So we have minus 4, minus 8, minus 5. What is the value of f of negative 2? Negative 17. So this is our answer for f of negative 2. That is super chunky. So it becomes order of operations. So we'll deal with our exponents before we deal with this would be a multiplying, essentially. When they start tossing variables into these pieces, we treat it exactly the same way. So just because we're substituting into x doesn't change what we're going to do. We're still going to take and substitute in, we've got our opposite of 2x squared plus 4 times 2x minus 5. So we're still substituting that 2x in place of the x. And we're still going to simplify as much as we can. We would like to have no parentheses at the end of this. So then we got to be careful with our order of operations again, especially when we have negatives in front of powers. There's like a little chunk on my screen, it's driving me nuts. So what happens when we square our 2x? 4x squared. Plus 4 times 2x, 8x, minus 5. Is there anything else we can simplify? Nope.
Oh, you don't?
That's our answer. There's no more parentheses to simplify. We don't need to try and factor this to solve. We aren't asked to solve it. All we got to do is get rid of our parentheses. Me causing chaos in my drawer. There's a spot of dirt on my screen and it's driving me nuts. Because it's causing texture under the stylus. So. There we go. Better-ish. Okay. So then we have one more of these. I'm going to change the view real quick just because I have that one very, very close to the wall. There we go. Just for the setup part. So we're going to do our f of x plus 4. And again, just like the others, we're going to substitute that in place of the x. This guy's going in place of x. So when we set this up, we're going to have our opposite of the x plus 4 squared plus 4 times our x plus 4, and then minus 5. So when we substitute that x plus 4 in place of the x, we get a statement like this. This one is going to take us more steps to simplify. Because what can we do to try and simplify this? What are we going to do first? The square. Let's deal with that exponent first. So we're going to have our negative sign out here. What is x plus 4 squared? X squared plus 8x plus 16. That's just the x plus 4 squared. That minus sign's still out in front of the whole thing, so I still have parentheses on it. What are we going to do with this? Distribute. I'll distribute this 4. So we're going to have our 4 times x, giving us a plus 4x, plus 16. And then that minus 5 is coming in too. Questions on that step? Because what should we do next? Distribute that minus sign. Ugh. So we have our minus x squared, minus 8x, minus 16, and then everybody else is just kind of hanging out, plus our 4x. I'm just going to put them both in here, plus our 16, minus 5. Oh, where the 8 came from? When we multiply this out, so we get our x times x for x squared, 4 times x, and x times 4. That's where the 8x comes from. And then plus our 16. Think of it this way. X plus 4, x plus 4. Think of it that way. We got to get that middle term. Important piece. All right, so now where do we go from here? Combine some like terms. We got a bunch of like terms in here. So we've got our minus x squared. That's our only squared term. I've got a minus 8x plus 4x minus 4x. And then we get our minus 16 plus 16 minus 5. Minus 5. Okay, so even when they give us kind of funky things to put in here, it's not that different than when we just do it with numbers. Okay. Questions on these 3? Oh, let me put a box around it just so we can say this is our answer. This is our f of x plus 4. That's our answer. Okay. Any questions on these 3? Because there's a whole section in the homework that works with these specific substitutions. And there's a couple of them that are kind of funky. So we're going to practice with using a minus f of a plus h, like all these things. There's a lot of stuff in here. And they're in the homework, like this would be a part A and a part B and a part C, D, E, like that kind of stuff. That's on questions 6, 8, and 12 are very much like this. So it's the same kind of deal. We're given a function and we're substituting pieces in. Some of them are, you're going to look at them and go, really, just like that? Yes. Because when we're looking at f of a, and we already have that f of x is our 5x minus 2. That is the least straight line I've ever drawn. There we go. All we're doing here is we're replacing the x with an a. That's all it is. So this is going to be 5a minus 2. Replace the x with an a.
And that's the answer?
Yep. When we get to the f of minus a, same kind of deal. We're going to replace the x with a minus a. So we get 5 times our minus a minus 2. How can I simplify 5 times minus a? Negative 5a minus 2. So our f of minus a simplifies down to be that. This one is this guy. That's just our answer. What can we do for this third one? Minus f of a.
Does it make the entire function?
Because what we're doing is we're taking f of a, the whole thing, times negative 1. We actually already know f of a. Oh snap, look at that. So you can either substitute a and times by negative 1, Or we can go, oh, wait a second, I know f of a. That's this guy over here. So that's going to be the same thing as minus 1 times our 5a minus 2. So we're going to get negative 5a plus 2. So where the minus sign is important. It does make a difference. But that's our answer there. Questions on those three before we do the bottom row of chaos? Okay. So in this bottom row, we start working with another letter in here. We've got H as well. Means the same thing. We're still working with replacing the X with this piece. So I'm still going to substitute into my equation exactly how we started. Our 5 times A plus H minus 2. Substituting that in place of the X. What can I do here to simplify it? Distribute the 5. So I need to distribute this 5 to the A and to the H. So we're going to have our 5A plus 5H minus 2. Is there anything else I can simplify on that? Nope. That's our answer there. Then we'll look at our middle one here, f of a plus f of h. This one is going to take a little bit more space, but not super far, because f of a, we know we've done that, or we can substitute it in ourselves. F of a, so we're going to have our 5a minus 2. And then we're going to add our f of h. So we're going to plus, substituting h in again, 5h minus 2. So we've got our f of a, f of h, and we're adding them together. Just gonna zip a little bit over here. So when we simplify this, I've got my 5a that I can't really combine with anybody. I've got my 5h that I can't really combine with anybody. But we've got this minus 2 and another minus 2. Minus 4. So our f of a plus f of h gives us this 5a plus 5h minus 4. So it's not exactly the same as the last one. It's similar. It's got a lot of similar pieces. But it is different to take and add the two functions than it is to add the two variables. I'm just going to give myself a little bit more space over here because I'm right against the wall. So we have one more to do on here, and it's a little icky. I promise it's actually not that bad. And we actually know a lot of these pieces. We've already filled in f of a plus h. That was this guy over here. We've already filled in f of a. That's this guy here. So when we're setting up this last one, the sixth one, we actually already have simplified versions of a lot of these pieces. Because our f of a plus h is this guy from over here. So I can just put that. I already know what it is, simplified. That's my 5a plus 5h minus 2. That is f of a plus h. This guy. And then we want to subtract f of a. Well, f of a is this guy. So we need to subtract 5a minus 2.
Wouldn't you just use the negative f?
You could also use this one and add this guy. That's also totally valid. And our denominator right now just has an h. I'm going to zoom in just so we can see this, just this bit. Okay. So then we can simplify this numerator a bunch. So we're going to have our 5a plus 5h minus 2. Then we're going to have our minus 5a plus 2. And when we come through to try and simplify this numerator, what do we see happening? The 5a's are going to cancel out because I've got a plus 5a and a minus 5a. What else? The 2's. So all we're left with is 5h over h. So what does this simplify down to be? The h's cancel. And we're just left with 5. So this whole hot mess equals 5. This fraction thing, we will see several times this same exact pattern. It has a special name. It's called the difference quotient. We will talk about that more in detail later. Well, let's practice another one of these. So we're going to do that same kind of set. We're going to find our f of a, f of minus a, minus f of a plus h. And we could give you any kind of function here. We don't have to do like these. We can give you like square roots. We'll give you all kinds of funky stuff. So they start out pretty simple. If we have f of a, substituting just a in place of our x, we're going to start out with just having a squared plus 3. So that's our f of a. When we have our minus a, and we substitute that in, minus a, which is being squared, and then add 3. What happens when we square the opposite of a? It's still just going to be whatever a is squared. It's the same exact thing. So f of minus a gives us the exact same answer. So our f of minus a is also a squared plus 3. So what are we going to get for our minus f of a? How do we set that one up? Yep, negative a squared, because we would have the opposite of a squared and the opposite of 3. So we're going to have our minus a squared minus 3. It's this thing, whoop, that's not the laser pointer. This thing times negative 1. So we have all those pieces. Those ones aren't awful. The bottom row is a little unpleasant. But we're going to go through it. So when we start getting into things like this a plus h, that's when we're going to have to make sure we're substituting in carefully, because we need to have our a plus h as a quantity squared plus 3. Yes, we want to multiply that out. So if it helps, write them out as 2 separate parentheses so we do not forget that middle term. I'm not saying you have to, but it'll help for some of us. So what is our a plus h squared? A squared, 2ah plus h squared plus 3. Okay. Those aren't awful, not too brutal. F of a plus f of h. Do that one. See if we can simplify that one. What do we get for our f of a plus f of h? Yep. We should get a squared plus h squared plus 6. Because we're taking this with our a squared and this with our h squared. So that's exactly right. A squared plus h squared plus 6. Then we get our bestie friend, the fractiony guy. But luckily, we already know a lot of the parts of it. So we already know what our f of a plus h is. We already simplified that. A plus h, that was this one over here. So I can write that as my a squared plus 2ah. Yes, dear? Yep. I'm just going to finish this up. Plus 3. Because this guy is this guy. There we go. And this one's not done yet. We got more to put here. I said it was no cheap deal. So in the rest of this denominator, you can either think about having our minus f of a, can you touch it? Minus f of a, or you can use your minus f of a. Either way. We're going to wind up with our minus a squared minus 3. That 2 looks weird. There we go. And our denominator just has the h. So we need to simplify this. In our numerator, we've got some things happening. The a squareds cancel. And the 3's cancel. So we have left in our numerator 2ah plus h squared over h. And this can simplify. What are we going to be left with in our numerator when we simplify? 2a plus h. If it helps, think of this as factoring out a GCF of h over h, like this, so that they cancel. So that our answer is just this 2a plus h. If it helps you to write it as a factoring out to then cancel, that is totally valid. Just make sure we take the h out of both of the pieces here. This is what our piece here is. Okay? So we will work more with 3-4 tomorrow. We got to that one. I'm cool with that. I'm going to put up the numbers. Quiz 5 is for tomorrow. That's sections 1, 2, and 3. So everything we've done since the chapter test.
I have a concert and a quiz tomorrow. Yay.
Today's Wednesday.
Yeah, our concert's tomorrow.
I know. There was a different question. Okay, I'll leave those. Yes, I have. Would you like individual crafts or one big piece? I was gonna say, I also have, like, I have vast varieties, and I can print more.